Have you ever looked at your data and wondered how it sounds? No, of course you haven't. No one would. That's just silly. But look, I've done 79 videos so far, and to celebrate number 80, I'm doing something fun that I want to do. Oh, and I'm Jeff, and this is Off the Charts with Jeff. So here we go. Let's get started and get this recorded before someone gets wind of what I'm doing and beats down the door and shuts off the camera. So let me show you a quick sample that I created to show you how I was able to visualize the sound of my data. This is honestly a bit of a flex in terms of just how far you can take Dundas BI, because it really is a powerful tool. And if you have a non-standard goal in mind, like what I'm about to show you, it can certainly get you there. So here it is. I've taken one of my favorite sales data sets and visualized it using a line chart. I've also added a keyboard or piano at the bottom so that we can play it and visualize our notes on the keyboard while our data plays. Also, watch this. Now let's hit play and see how our data sounds. Oh, and I took the liberty of adding some lyrics so that you can sing along too. Have fun. I know you're probably thinking that I should get this thing on Spotify as soon as possible so that we can go triple platinum. But unfortunately, most people don't realize that in the BI industry, you can't go triple platinum. The best you can hope for is triple pie chart. Either way, I'm looking forward to those royalty checks. Now on to the educational part. How did I make this? First, we need to normalize our data set. Since Western music is based on an 8-note musical scale, I'm going to apply several formulas to adjust our data to fit within this scale. First, we need to calculate the top and bottom values of our data set. To do this, we add a chain of formulas. So using the bottom function, we can first calculate the lowest volume of our data set. Then we call the top function, and we can calculate the highest volume of our data set. Once we have these, we can add another formula to calculate the range by doing a simple subtraction. We're getting there. Next, we want to zero the data set by subtracting the values from the lowest values. The reason I'm doing this is because I want the lowest value to represent our lowest note. Finally, we'll take our zeroed values and calculate the ratio to represent them as a single value between 0 and 50. If you're doing this, don't try a range as large as 100. I'm not sure if you've ever experienced music with a 12-octave range, but it's extremely uncomfortable, and my cats, Pumpkin and Boo, ran away terrified when I tested it. Scaling this data into an integer values between 0 and 50 gives us a nice, comfortable, approximately 6-octave range. Your coworkers and your pets will appreciate it. Also, since we're dividing, we don't want to divide by 0, so there's a quick check at the top to make sure we're not doing that. So that's it. Now that we have our data normalized between 0 and 50, we don't have a completely ridiculous octave range to work with. Now the piano keyboard. This is just a map control. The map control in Dundas BI is ridiculously powerful in terms of just what it can do. And I simply drew a piano using SVG and loaded it in. Also, if you haven't seen my recent video on the map, I do highly recommend checking it out. It's creatively named, What Can You Do With the Map in Dundas BI? I actually came up with that myself. Anyway, once we have the map loaded, it's just a simple script. We need to do a hit test to see which shape was clicked. We uncolor them all in case one was colored from a previous click. Then we pull the name of the shape, for example, C#2, and we play it using tone.js. This is available on GitHub and it was super easy to implement. Now let's just take a quick look at the play button. Just like the piano code that I just showed you, I set it up using tone.js. then we're basically walking through our data set, looking at the values and assigning them a note and an octave based on their integer value between that 0 and 50 that we previously scaled. And of course, we need to play the note. The only other code we have in here is just some simple aesthetics things like highlighting the keyboard and changing the note name. Not necessary really to make this work. Pretty cool, huh? Now just think, if I'm easily able to implement a laughable and completely made up use case like this, no matter what requirements business is going to throw at you, a tool like Dundas BI is going to help you get there. Now that's all for now, and thanks for watching. Oh, and don't forget to watch the other 79 videos that we've created so far. There's a large list of them and definitely something for everybody. I hope you like this.